This is a distance example. So in this example, we have to find all points on the curve y equals the square root of x from 0 to 3 that are closest to and the greatest distance from 0 to from 2, 0. So we have the curve y equals the square root of x, and 1, 2, 3. The greatest 2 and the farthest distance from 2, 0. So we basically need to make this distance the shortest distance, and then we need to maximize and minimize the distance of this segment, which is 2, 0, and x, and the square root of x. So our distance formula. Okay, so our distance formula. Difference of the x's, difference of our y's. Simplifying that. X squared minus 4x plus 4 plus an x. Okay, now taking the derivative of that. Our derivative, 1/2 x squared minus 3x plus 4 to the negative 1/2 times by the derivative of the inside, which is 2x minus 3. So our derivative, a little simplified out, would be 2x minus 3 over 2 times the square root of x squared minus 3x plus 4. Okay, so set that derivative equal to 0. And I get 2x minus 3 is equal to 0, so x is equal to 3/2. Now I also need to look and see when that derivative is undefined. So what you want to do is you want to look and see, okay, can this quadratic function, and there should be a plus there, is that quadratic ever equal to 0? So if that function is equal to 0, okay, so how do we figure out if a quadratic function is equal to 0? We do the discriminant, b squared minus 4ac. B squared is 9 minus 4ac. That's definitely going to be less than 0, so our roots are going to be imaginary, so our only possibility is 3/2. Now notice what we also have here. They also give us a domain restriction. So they give us some possible values. So they give us some possible values to check. D of 0, D of 3/2, and D of 3. Since they give me an interval, I can just plug these values into my original function to figure out which one's the smallest and which one's the largest. When plugging those in, we get a 2 there. We get a root 7 over 2, and when we plug in 3, we get a 2. So 2 is definitely bigger than root 7 over 2, so this is a max, and this is a min. So again, make sure you're answering your question. For our question, we need to know all points on our curve. So I know the x coordinates, so our max distance points are 0 and something and 3 and something. When I plug those values in because they have to be on the curve, so if I plug 0 in for x, I get a 0 there. When I plug in 3 for x, we get a root 3. So our minimum now, distance points, is when I plug in 3/2 into my curve, and that's going to be the square root of 3 over 2. And again, I'm okay if we don't simplify that. We are good from there. So that's how you would do that type of example.